Okay, so this video will take you through the final problems of the year. And for the video, we're going to do 2 of them together, and then you're going to try the third one on your own. If you are in class, we're going to break this up into smaller problems and kind of work them in groups and then come together, and we're going to just work the problems a little bit differently. But if you're trying to make this up from home and you weren't in class and you don't have the benefit of that immediate feedback, what I'll do is I'll go through the first 2, and then you will be on your own for the final problem, and I will give you some hints, and that'll kind of compensate for doing them on your own. Forgive my handwriting. I think I have sprained my thumb, and it sometimes hurts a little bit to write. So for the first one, in a trig identity, essentially what you're doing is you're going to work with one side and get the other side to match it. And so in this one, we know that what we're going for is 1. Okay, and so when I am done with the left side here, I should get the left side to be a 1. Now, a common strategy that is used is get everything in terms of sines and cosines. So if you see me looking off to the side here, I did the problem out earlier, and so I'm just kind of looking to see what I did. So to do this, here's what I keep in mind. Secant x is equal to 1 over cosine x. And if I'm honest, I do get a little bit lazy sometimes, and I'll just write secant without the angle, like the x for the angle, but I'll try not to do that in the video. Tangent, we know, is called my phone ringing. Okay, we're back. That was about senior grades finalizing. So we are at tangent is sine over cosine, and then cotangent. Now, cotangent is the reciprocal of tangent, but what is often more useful, again, is to put everything in terms of sines and cosines. So instead of saying 1 over tangent, we're just going to take the reciprocal of tangent, which would be cosine over sine. And so what we're doing there is we're taking the reciprocal of what we know tangent is. So tangent is sine over cosine. So that means cotangent is cosine over sine. So what I'm going to do over here on the left is for secant, tangent, and cotangent. Okay, if you can see where I'm pointing, I am going to do these substitutions, and it's going to give me a hot mess of fractions, which is why we've been studying fractions. Okay, the reason why I said this is why we're going to go back and we're going to look at fractions with unlike denominators and all that sort of thing is because of the applications for higher math. So secant becomes 1 over cosine. And then I'm going to have like a gigantic fraction bar because the cosine is going to be in the denominator. Minus tangent is going to be sine over cosine. And then we have the big fraction bar, and then we have cotangent in the denominator. So that'll be cosine over sine. Now, the reason we do that is because we know from experience with working with these fractions is we can get stuff to cancel out. But in order to get stuff to cancel out, we need to kind of have all the same things. So you can't cancel like a tangent with a cosine, but you can cancel a cosine with another cosine. No, not every cosine, just if you have one in the numerator, one in the denominator. So now we're going to go through and do the division is multiplication by the reciprocal. And I'm going to do one little notation here. Remember that that is cosine over 1. So this is my division symbol, and I'm going to rewrite those as multiplication by the reciprocal. So this will be 1 over cosine, and instead of dividing it by cosine, I'm going to multiply it by 1 over cosine. Oh, wait a minute. Okay, yeah, that was right. All right, and then I have my minus sign, and we're going to have sine over cosine. And again, instead of dividing, I'm going to multiply by the reciprocal, which will give me sine over cosine. Now, multiplying fractions, we go straight across. So 1 times 1 is 1, and cosine times cosine is cosine squared. minus sine times sine. So sine times sine is sine squared, over cosine times cosine is cosine squared. And what I love about that is that I do have a common denominator. So yay. So we're going to just move this back up here. So that'll give us 1 minus sine squared over cosine squared. Okay, now right here, I'm going to kind of separate that. We did this one. We know that sine squared plus cosine squared is equal to 1. All right. Now you can actually make a substitution in that way. So one of you might be watching this and you know who you are. Like, ooh, that was me that did that. Actually did a problem earlier this year where just did a direct substitution in instead of changing, instead of doing the algebra. And we can do that right here because that might work out. So instead of 1, I'm going to use sine squared plus cosine squared is equal to 1. So sine squared plus cosine squared. And then we have a minus the sine squared is still there. All over cosine squared. And then if you look, sine squared minus sine squared is 0. And so that will cancel out, leaving me with cosine squared over cosine squared. But anything divided by itself is 1. Ta-da! So if you need to, I know I worked through that, like, but you probably need to like watch, listen, copy, like it's going to take you a little bit. So if you need to pause the video and now copy it down, if you got delayed, you need to rewind it, do what you need to do. But the work starts over here and it works top to bottom and then comes over here and goes top to bottom. So on your page, it is going to be fairly lengthy. Okay. And this is like a college level problem. So if you're like, ugh, like that was really awful. Yeah, kind of. But also I believe that you can do it. Like this, you're going to follow along. Okay. And what I want you to get out of this is 2 things. One is the importance of like the fractions. Okay. So why is knowing how to work with fractions and find common denominators? Why is that an important thing? But also just what is an identity? Like how do we make these substitutions? What are some of the strategies that work? And I got this worksheet of them, which you can't really see, but and I had to pick a couple off them. But honestly, I didn't know how to do them when I first started doing them. Like you just kind of start doing some stuff and then you see what happens. So hopefully I delayed long enough there for you to catch up with the writing. If not, pause the video. All right, so here's the next one. So we're going to take secant sine over tangent plus cotangent, and that's going to be equal to sine squared. So we know that we're working towards getting a sine squared. Now, what I plan to do in class is to give secant x sine x to like one group and tangent x plus cotangent x to another group and kind of let the groups like work on the smaller problems individually. And I'll do that for the one that we just did as well, so that we're breaking it down and then kind of putting them back together. Now for this, I'm going to use the same strategy. We're going to try to get everything into sines and cosines. So 1 over secant, or secant is 1 over cosine. Tangent is sine over cosine. And cotangent, we kind of went over that, is 1 over sine. But again, like reciprocal just means it's going to be cosine over sine. And I'm just going to do a direct substitution with those things. Okay, we're just going to go in and do a direct substitution. Do we necessarily know where it's going to go from there? No, not like we don't necessarily know. But we're going to find out. It's like an adventure. It's a puzzle to be solved. Now, for space purposes, I'm going to come over here. So 1 over cosine times sine, that's my numerator, all over sine, tangent, which is sine over cosine, plus cotangent, which is cosine over sine. And I can just make it a smaller fraction bar. Okay. Now in the numerator, 1 over cosine times sine, and that's like sine over 1. That is equal to sine over cosine, which you might recognize. Oh, that's tangent. Indeed it is. All right, now in my denominator, we actually did this one out. So if this looks a little bit familiar, this is probably in your notes from an earlier lesson where the only problem that we were doing was sine over cosine plus cosine over sine. To add those fractions, we need to have a common denominator. And to get that common denominator, what we're going to do is multiply by 1 in the form of the other denominator. So it's going to be sine x over sine x on that first fraction and cosine x over cosine x on the second fraction. So we will have sine x times sine x is sine x squared over sine x cosine x plus cosine squared over sine x cosine x. And here you've got a couple of options. I'm of a notion, I think I'm going to add those fractions together in my denominator before I deal with the super huge fraction. So there we go. So I'm going to keep the numerator the same. Okay, I'm not doing anything with the numerator. And in my denominator, I'm now going to add those together. So we have sine squared plus cosine squared all over sine x cosine x. Okay, again, if you need to pause this, like it does look like a lot, like it really does. I'm not gonna argue that, but also each step is just like one step in the process, so we're not biting off too much. Now here is where I think I'm going to do the dividing, is multiplying by the reciprocal. So instead of sine x over cosine x divided by, I am going to go ahead and do multiplying by the reciprocal. So this will be sine x cosine x, and I'm going to sneak in another little step. Well, should I sneak in it now? We won't sneak in a step. Okay, now here's where it gets fun. All right. Anything that you see numerator, denominator, you can cancel some stuff out. So a cosine and a cosine. And then right here, sine x plus sine squared plus cosine squared is equal to 1. And so I have the cosines that have canceled. This is equal to 1. So dividing by 1 is just dividing by 1. And what am I left with? Sine times sine, which is sine squared, which is what I wanted. You look here, I'll change over to pointer. There it is. Sine squared, sine squared. So I got where I wanted to go. So ultimately that was like one, if you consider this a step here, that might be a second step. So 1 step, 2 steps, 3 steps, 4 steps, 5, and then the canceling might be 6 steps. So really, that's a 6-step problem. Is there a lot of writing for all the steps? Yeah, there's a lot of writing for all the steps, but it is a 6-step problem. So if you need, again, if you need to pause, you're just pausing, write it down. Try not to go into autopilot too much. Make sure you are like paying attention to what you're writing, and like you, if I were to ask you, hey, what happened in this step, that you could explain what happened in that step. Now, for this last one, you have secant minus tangent sine times or is equal to cosine. And for this one, what you need to know, so I'm going to give you like, what do you need to know? You need to know that secant x is 1 over cosine. And you need to know that tangent x is sine over cosine. And then you need this one right here, that sine squared x plus cosine squared x is equal to 1. Okay, and so you're going to end up with a 1. Okay, now here's all my hints. Okay, so hints. Turn on volume if you have not had it turned on. Okay, this 1 you're going to replace with sine squared plus cosine squared. Don't do it at the beginning. Okay, so like come over here and start the problem. All right, that sine squared plus cosine squared is equal to 1. And honestly, I think after that, like you want to remember that to multiply fractions, you multiply straight across. So if you have, say, I don't know, you might have like 2 over 3 times 2, that would be like 4 over 3, or you might have like 2 squared over 3. Okay, so that, oops. So that might make more sense once you start the problem. Okay, and I want you to see what you can do with it. Now, basically you're going to take this thing right here, and you need to get it to look like a cosine x. I did it in 1, 2, 3, like 4 steps, maybe 5. So 5 steps. It was the simplest of the 3 ones, so like it doesn't have any compound fractions, so you won't see any compound fractions in this one. All right, so show me what you got. Upload this to Focus if you were absent, and stay tuned for the last assignment, and we're on the home stretch. So if you have questions, let me know.